So welcome everybody to academic session B on the second day of this conference. This session is going to be on inflation forecasting, modeling, and the Phillips curve. My name is Kilian Rieder, and I'm an economist here at the Economic Analysis and Research Department at the OeNB. Today we have 5 very exciting presentations lined up for this session. And I promise you will learn a great deal from their contributions, even though perhaps we are pretty far away essentially from that age requirement that the government yesterday sort of made when he talked about, the Volcker shock age threshold essentially. So in terms of housekeeping, we'll be very strict on timing as the speakers have been informed, of course. So we have about 10 minutes per speaker and then 5 minutes Q&A. And you will also have, of course, the opportunity to approach the speakers during the break or by email and so forth. I think they're happy to come back to you. Now, one thing that is special about this session today is that it is also some sort of a Netflix on-demand academia session, because we will have 2 contributions that have sort of, that couldn't come in person, and so they pre-recorded their video. And unfortunately, we will not be able to discuss with them, but at least we'll be able to see their contributions in form of a short video that we'll be showing here as well. So that's also, in fact, how we're going to start with one of the presentations that was recorded, and in this case, it's the presentation by Roland Meeks. Roland holds a PhD from Oxford University. He's currently a senior financial economist at the IMF, and before that, he worked at the Bank of England for a couple of years. So we'll have Roland up now, I think, if that works.
Good morning, everybody, and thanks for watching this recording of me talking about my paper, Heterogeneous Beliefs and the Phillips Curve. The views expressed here are mine and Francesca's and shouldn't be attributed to the IMF, its management, or its executive board. Okay, so let's begin by looking at some data. It's widely agreed that expectations matter for inflation. Here are inflation expectations, in this case from households in the US. This data from the Michigan survey is widely used. It's widely used because it helps with forecasting inflation. It helps researchers to avoid econometric problems that crop up when you use full information, rational expectations, assumptions for estimating, and because it tells you something about how expectations are actually being formed. But these plots are just to give you a flavor. So what are they? Well, the little crosses are actual point forecasts that households have made for inflation, reported by survey respondents. I've jittered them side to side and up and down so that all the crosses don't just kind of lie on top of each other and you can see how much data there is. The solid lines are consistent estimates of the density functions that these data are drawn from. I stress they're consistent, okay? So in each case, I'm showing you 2 significant dates. On the left, you can see in blue the distribution of households' expectations just before the collapse of Lehman Brothers in 2008. And then in orange, a month, one of the months just following the collapse, you can see another distribution. On the right, I'm showing you the month just before the COVID-19 pandemic started, and then where we are pretty much now in March 2022. Note also that the first chart, the one on the left, refers to a year ahead expectation, and the second to long-term 5 to 10 year expectations. So these distributions are sometimes complex. You can see multimodality there in the left-hand chart, and they're clearly time varying. Big disruptions lead immediately to big shifts in expectations. Households aren't just extrapolating from past inflation experience here. That's what people often say. And households aren't necessarily wildly off base in terms of their forecasts either. inflation, as experienced by individual households, is known to differ hugely in the cross-section. And research has shown that these individual experiences shape forecasts as well. So again, this is just a flavor of the data. We have monthly observations like this back to 1978 in some cases. We have hundreds of thousands of data points. Why is this important? Well, because research which uses this data in inflation modeling, generally speaking, stops at consensus, a mean or a median, a summary of the data you see here. The differences of opinion that you can see very clearly in these charts are taken to be irrelevant for inflation, but we show that they aren't. So what about some theory? When there are differences of opinion, so that everybody holds their own belief, which I'm just calling E of K here, where that doesn't have to be any kind of conditional expectations operator, just a forecast. The micro foundations of the standard New Keynesian Phillips curve fail in general, unless you make some very strong assumptions. If you do the derivation, you'll find that an additional term, which I'm called delta, and it's in pink here, appears in the Phillips curve. And that delta captures differences of opinion about reset prices, assuming you're using the standard time-dependent pricing framework. So now we have a Phillips curve which has a consensus belief, this average, which is E bar, just averaging across everybody's beliefs. And we have a differences of opinions term. Okay, so we have a Roberts or Koibion, Gorodnichenko, and Kamdar type setup for the Phillips curve, but with an extra term. So, how about taking this model to the data? So we're going to suggest that this extra term in expectations that appears in this Phillips curve can be approximated empirically by something that we do observe. We don't observe reset prices, but we do observe the distribution of inflation expectations. We are going to rely on there being some systematic relationship between reset prices and inflation, but we don't know exactly what that is. And so we're going to allow this function, which is in blue here, in light blue, which we've called gamma, will allow that function to be estimated from the data. Okay, so we are going to replace the this cross-section distribution of beliefs about reset prices with some function of the cross-section distribution of beliefs about actual inflation. Okay? So the Phillips curve that you get once you make that substitution is the one which is appearing at the bottom of the page now. And when you look at that and think, well, how do I estimate that thing with an integral in it? Well, it turns out that you can do it. And you can do it because the distributions that you saw earlier on in the presentation at the very beginning can be decomposed using a principal components method, which is tailored to functional data. So these the data that we have is, remember, it's in the form of these distribution functions. So you can take principal components of that thing, and then you can use the principal component scores to turn the functional regression into a principal component regression. You can also test hypotheses, very importantly, that the delta term actually doesn't matter at all, that the standard practice of using consensus beliefs is just fine and all you need. And you can do that using an F-test essentially on these components. This is a nice result in Kong, Stasu, and Macy's paper. I should mention as well that although I don't talk about it in this presentation, there's a lot of structure in the distribution functions that I showed you. So although they're very complicated, principal component analysis allows you to uncover a really quite interpretable factor structure. And it shows you that with 3 principal components, you can explain about 95% of the variation in those distribution functions. So you can compress a lot of that information that I showed you earlier down very efficiently using these methods. So a lot of the paper is about exactly that exercise. Okay, so how about some results? I'm going to talk about this just very quickly, given the time. Let's focus on the left side. That's the US data. What you see here is a Phillips curve, which is very familiar from, work by people like Larry Ball or, John Roberts, Corbijn and Gorodnichenko. So this is a regression of, in this case, quarterly inflation on the CBO unemployment gap, on lagged inflation, because people include that, and on this consensus expectation. And you can see in column 1, you have an almost perfect hybrid Phillips curve. So hybrid meaning forward and backward looking. But as I mentioned earlier, the problem with this Phillips curve is that it disregards heterogeneity. In column 2, we have these differences of opinion appearing. So I've included 3 of the principal components that I mentioned earlier of these distributions. And that statistic, the TF statistic, which is listed here as a value of 14.2, has a p-value of 0. In other words, statistically, differences of opinion matter alongside average expectations. And moreover, when you include those, there is no role for lagged expectations anymore. It's only about there's no role for lagged inflation anymore. So there is no hybrid Phillips curve. It's just about the forward-looking component, which is interesting in itself. But the implication here is, of course, that statistically, you're misspecifying the role of expectations if you omit the delta term, the differences of opinion. Okay, so that's the statistical evidence. In this chart, we can get a sense for the estimated contribution of expectations to observed inflation over the very recent past, and therefore economic significance. So observed inflation month on month at an annual rate is represented by the little dash lines. The green bars are the portion of that observed expectation, which is explained by expectations according to our model. And then the orange bar is everything else, oil prices, the unemployment gap, and so on. Okay. The model that I'm using to explain inflation is just a more general version of the one you just saw. It allows for near-term expectations and long-term expectations to be sort of weighted together. And it allows 2 distributions, the distributions of both near-term and long-term expectations to matter. So the message to take from this chart is that beliefs, expectations, can exert a considerable influence over actual inflation, in this period. In other periods, expectations are relatively stable, and obviously the contributions would look very different. But in this period, expectations have contributed significantly to inflation. But of primary interest to us in this talk is how that influence can be decomposed. So let's look at that. This final chart zooms in on the green bars, the expectations components that I just showed you. The green bars here are identical to the ones that you just saw, but their height has been normalized so that January 2020 is 0. That means we're looking at the change in the expectations component of the model relative to January 2020. So 4 subcomponents appear: the consensus about the year ahead and about the long term. Those are the darker bars. And then the difference of opinion components in the lighter bars. So the overall contribution of expectations to inflation is shaped strongly by these heterogeneous beliefs. Take a look at March 2022. You can see that the increase in the consensus about future inflation, the dark bars, has raised actual inflation by about 3 percentage points since January 2020. But differences of opinion matter too. In fact, they matter about as much as consensus does, also accounting for about 3 percentage points. Think back to that very first slide that I showed you, the slide with the data. It's not just that long-term expectations, for example, are higher on average. It's also that those beliefs are more dispersed, more skewed, and more outlying. And it turns out that that matters statistically and economically for how we understand inflation. Okay, so here are the main messages. First, that distributions of beliefs about future inflation, in this case household beliefs, are complex sometimes and time varying, but also that they have a factor structure that we can exploit and understand. Second, heterogeneous beliefs modify the standard Phillips curve, and you have to test the extended model if you want to correctly specify the role of expectations. We find that models that omit these distributions do misspecify the expectations component of inflation, and that heterogeneous beliefs can make an economically significant contribution to inflation, especially in periods of macroeconomic dislocation. That's everything. Thank you very much.
Okay, I apologize for the bad video quality. I hope you could still follow the presentation somehow from the audio. Since Roland is not here, we cannot have a Q&A session with him, although it would certainly be quite informative given the discussion we had yesterday with Claudio Borio exactly on this kind of inability of the new Keynesian Phillips curve on perhaps adequately forecasting transitions, for example, and I think the role of distributions would be quite interesting to discuss in that context. Anyway, I think it's time to move on and to go to our first real life presentation. We'll have Philippe Coulombe who will present. First up, basically, Philippe holds a PhD from UPenn and is now an assistant professor at the University of Québec. Philippe, the floor is yours.
All right, well, thanks for having me. So I can assure you that everything from now on will be in high resolution. We're not going back. So this paper is about applying neural networks to understand inflation. And here the word understand is quite important. We're not only going to forecast inflation, but we're going to build a deep learning model that actually can help us learn something about key drivers of inflation like economic slack and inflation expectations. So let's see. All right. So the road to hell is paved with unknown unknowns, and you probably heard these little two words put next one to another before. Anyway, this graph is I just took vacancies, help-wanted index in the States and unemployment rate, and I scaled them, and just put them so that they correlate positively. And this is just to tell you that there are many measures of economic slack. Obviously, there's detrended GDP, there is unemployment, there is filtered unemployment. I could use vacancies, could be also a reasonable measure of slack. And sometimes they're very close. If you look at the 90s, the early 2000s, but suddenly, around the 70s and also during the pandemic, they were, quite different. And a priori, it's not certain. I mean, it's not clear which one is the best proxy for economic slack, right? I mean, theory is rather silent on what measure of economic slack should be used for, modeling inflation. So what are we going to do? I mean, what's the situation? Obviously, the last year and a half suggests that some form of Phillips curve is alive. However, if we look at traditional econometric specification, linear specification or time varying parameter or anything, that econometricians have been focusing on mostly for the last 20 years, it's sort of said, it's dead. Now, on the other, side of the spectrum, artificial intelligence methods have the virtue of being rather agnostic. So you have data, you don't know what the data generating process is, you can, use these methods to sort of learn how the data moves together. However, as you probably heard, these tend to be black boxes. So if we have to do policy or understand or forecast, obviously using these methods off the shelf might not just deliver the goods. So the solution that's going to be proposed here today is to nest a very flexible and general Phillips curve, PC, within the deep neural network. So we're going to tell the deep neural network, by the way, we're going to write its architecture, that we actually want to learn a very broadly defined Phillips curve. And the benefits are going to be better forecasts. It's going to be economic slack that's probably captured in a better fashion, at least seems to match the data much better, especially for the last year or so. And from a deep learning point of view, we're going to get interpretability, and this is absolutely important. When you talk to central bankers, oftentimes they care more about what drives the forecast than the forecast itself. So that's basically what we're going to be doing here. So that's going to be the only equation of this talk. So that's why I put it to be so huge, so you remember it. Anyway, that's a modern Phillips curve. It could be written as the sum of expectations, which we have sort of heard of quite a bit by now. So expectations, first term there, and I put theta t, so that means, as a time varying coefficient. Pi t is inflation a period later. The periods we're going to be using here are going to be quarters. It's all going to be US data, by the way. So US CPI a quarter later, driven by expectations about the future right now, plus gamma t times GT, so that's the gap, the output gap, or economic slack and its coefficient. And we have commodity prices and the time varying coefficient. These can have an effect. And then we have idiosyncratic shocks. So, the key idea of this paper is really to say, well, we in fact can see this very broadly defined equation as a very weird form of neural network, a neural network that we basically invented for this application. And the output from these three components that we've been talking about quite a bit around here, are going to be output from what I'll be calling hemispheres. Now, what are hemispheres? Where there are these things there. So if you've never seen these sort of graphs before, well, this is called a neural network. It's sort of inspired by the brain, loosely inspired by the brain, I would say. And the idea here, all these colors were going to be different hemispheres, and all these connected stuff are going to be neural networks, okay? And if you're not familiar with this sort of thing, and you're maybe more familiar with econometrics, think about this as very flexible machine that transforms an input into an output. Now, the inputs are going to be what? They're going to be stuff like, the first X is going to be stuff like any variable related to economic slack, like unemployment rate, GDP, and then maybe the other 80 variables you get in the FRED database. So we're going to put all that in the hemisphere, and the job of the neural net is going to be to create a summary statistic, a time series that will basically summarize all the information there is about economic slack in the big data set and create one series and add that with the blue stuff. The blue stuff will be, say, all the data we have on expectations. As this paper are going to be using the obvious stuff you get for the US, but you could easily throw whatever survey data you have in there and hope the neural networks to actually summarize whatever is relevant about expectations in there. And then the third hemisphere could be information that's relevant about commodities. So now the output of all these hemispheres, H1, 2, and 3, they're all going to be combined together linearly. And then that's this particular combination here, which we call the neural Phillips curve, that's going to actually give meaning to these different hemispheres output. Because in a typical neural net, if you look at neurons, that's what these little colored balls are. They're neurons. They're typically meaningless. But here, by this little structure that we're imposing, inspired again loosely from macroeconomic theory, suddenly these different parts of the neural network will have a meaning. All right. So first ingredient, lots of data. We're going to use the FRED quarterly database. It's used in all papers doing macro forecasting these days. Second ingredient, the neural network we just introduced on the previous slide. The job of the neural net is going to be to learn which indicators of economic slack, pressure are pertinent, learn what sophisticated transformation of them is relevant. Should we filter them? Should we take out the trend? Should we first difference them? Should we take a moving average? Stuff like that. And we're going to create a time series with explanatory power for inflation. So really by design, we're going to be extracting latent states like inflation expectations and the gap. So kind of quickly, although I have 5 minutes actually going fine. So these are forecasts, lots of them. These are forecasts for quarterly inflation, all right? So the black line is the realized value. As you can see the crisis, 2008, so we have the downward spike from energy prices, and then we obviously have the surge from last year. So this graph is straight from the paper as we released it in February of 2022. So obviously you can add one more data point there, which is quarterly inflation for the first quarter of this year. But the main point here, CKP is actually a typical Phillips curve. We use unemployment, it's filtered sort of endogenously with stuff like a Kalman filter and state-space model using Bayesian methods with stochastic volatility, sort of state-of-the-art Bayesian methods. And that's the sort of yellow-orange line. And that's why I wrote traditional Phillips curve. And as you can see, for the last year or so, this forecast, that's, has been severely biased downward. And it comes back a bit to what we were discussing yesterday in the policy panel. I think mostly comments by Claudio Borio was saying, well, we use the Phillips curve as sort of a guidance. Obviously, it's not the full answer, but it's still guidance. And the Phillips curve back last year was telling us, well, if I look at unemployment in the United States, or just, the output gap, in fact, it's telling me inflation pressures right now, this should go because, the big stuff, the stuff that should last for a while is actually telling me it shouldn't be so high at all. Now, the H&N line, the red line, that's the forecast for the hemisphere neural net that's introduced here. And then the blue line is just another variation on it. And as you can see, really, the red line, can capture pretty well the inflation surge, right? So, okay, that's kind of nice. The question is, how did that happen? So a typical neural net would just tell you that. You're pretty happy, but nobody really understands why it occurs. So the promise of this new methodological proposal is actually to understand what's going on behind the forecast. So here's a bunch of other plots, and I thought it's funny. I sent those slides to the conference, a week ago, and yesterday we sort of had this discussion about 1 exclamation mark, 2 exclamation mark. Now here's the third one, So sometimes you just see these things coming. Anyway, so what is this graph? 2 quantities, the output gap and the coefficient, okay? The red line is a typical, again, unemployment gap, and then the red line on the other side, it's its coefficient. And what we see is a typical story. We see that the Phillips curve has been mostly collapsing, especially in the last 20, maybe 30 years. And we see also that the gap, the red one, which now is updated up to data from the last quarter, we see that for most of 2021, the unemployment gap, according to the red line, was negative, basically was contributing negatively to the forecast. Now, if you look at the blue stuff is what comes from this neural network model that use a bunch of data, try to endogenously transform a variable so that they're relevant. And really what you can see from the blue line, quite a different picture for the 70s, attributes a lot more of it to, real economic pressure, but also, here are my 3 exclamation marks. You really see that the pressure, coming from the output gap or economic slack are pretty high, starting from late 2020 in the United States. So it explaining a bit why inflation actually lasted for so long. So the takeaway from the first panel is really to say you can get a pretty different picture if you use methods that are less restricted and more data. And I think this is key here because this variable is variable that we think about, when we wonder whether inflation is going to stay or not. The other one here is the coefficient on the Phillips curve. That's another interesting finding. Once you measure slack in endogenous fashion using this flexible approach, it doesn't really see the Phillips curve like it's dying at all. In fact, probably what most Phillips curve findings are telling us, obviously, is the link between particular variable and the Phillips curve that is collapsing. But if you actually build an endogenous measure of economic slack, well, you're going to find out that yes, indeed, maybe in the 90s and the 2000s, it was pretty weak, but it hasn't been, collapsing from that point on. Actually, it's been sort of back in shape, really, basically explaining the forecast that we see in most of the inflation as well. So that's like the second to last slide, loss of color, blue and red. These are a bunch of variable names. Obviously, I'm not expecting you guys to know them, but what we did here is an analysis to understand what is actually driving this latent measure of the gap that the neural network has learned. So the further the bar is, coming on the, well, that would be the right, that means it's important, and they're all ranked. So the first one there is L-pointed index. So that's a measure of vacancies, basically telling you more about the demand side of the labor market, whereas unemployment is typically, well, sort of a mix of both. AWH, man, that's the average hours work in the manufacturing sector. So that's sort of interesting. It's more about how long people work versus how many, a bit more about the intensive margin versus the extensive, or anyway, one or the other, but not the one that we typically use with unemployment. So, and then funny enough, we put unemployment in there and we put GDP, and the neural network doesn't seem to use them. And in fact, we even did a version where we filtered them the way people typically do, and the neural network did not use them either. So, kind of interesting stuff here. Obviously in the paper I discussed that in much greater detail, but let me wrap up for today. What are the lessons learned? Economic slack, and by the way, we also do the exact same exercise for inflation expectation. I just decided to skip it for today. But economic slack is relevant, that is relevant for inflation may not be captured by usual measures. Hemisphere neural network estimated with data through 2019 Q1, by the way. You know, we stopped the estimation in 2019 and then we project the thing. So it's not reverse engineering the last year. It's really just using old parameters to get what we just had a look at. And it, you know, nicely captures what we've seen last year, at least much better than typical Phillips curve. Of course, now there's been kind of a new, not new literature, but new papers saying, well, maybe we should revise the concept of economic slack. Maybe the natural rate of unemployment is actually, you know, kind of higher than we thought it was. So there are papers doing that in early 2022, but it's kind of nice that this sort of technology had a bit of a clue about this reevaluation to come, you know, using data prior to the pandemic. And I think, you know, more generally, maybe a takeaway message is that this work showed that economists can in fact use reasonably simple deep learning methods to construct economically interpretable forecasts that I think can at least inform a bit policy. That's about it. Thank you.
Thanks a lot. Okay, so we have one question here already, second one here. And I think that's about what we can take in terms of time.
Thank you very much. Very interesting presentation. One question about the interpretation of the results. Looking at the projection from your age, and looks like most of the inflation surge that we are seeing is basically endogenous or driven by the job market. As is what I understand, maybe I'm wrong in my understanding, and which contrasts with the interpretation of central banks, which actually attribute most of the inflation surprise over the last 12 months to shocks to commodity prices, which indeed, you know, went all over the place, and that was not probably expected. I'm not saying that you know, domestic factors have not played a role, but rather my question is, what is the role of the other factors? How do they, say, correlate in your model? Thank you.
Yeah, so we look at them, you know, obviously in the paper, but the model here, you know, is to forecast inflation, right? It's trying to get inflation in a quarter from now, and we also do a version for a year ahead. And what the model really learns is that, you know, commodities prices, of course, they can, you know, drive inflation. But if you want to think about what's coming next, you know, obviously what's going to be more important here is kind of the, you know, the economic slack part of it, you know, which has predictive power because it has persistence. And obviously, I guess what key point here is that indeed, if you measure economic slack perhaps in a better fashion or in an endogenous fashion, then suddenly you can find a better link between the two, and that link actually has statistical power and actually has, you know, you can forecast with it. So that's a bit, you know, what's being found here. But I don't think it, you know, necessarily contradict the other interpretation. Just change the weights, you know, on each of those things.
If we can be very quick with the question and the answer to the second one.
Right. Thanks, Martin Lach, European Fiscal Board. Actually, my question. It works. Sorry, I have to keep it closer. Sorry. I had a similar question to the previous speaker, because you say that you give an interpretation, but my sense is that you plug a lot of data into this neural network, and then you just give it a name based on a prior. So the variables that you have included in the variables that you interpret as the slack is essentially everything that you can find in a macroeconomic database. I'm exaggerating now a little bit.
No, well, maybe it's something that wasn't clear. You know, the hemispheres, the way they're defined, you know, we're going to put specific group of variables in each of these things. So obviously, we're not going to, you know, we're going to try to keep things separated. So really here is the idea of creating a summary statistic from a specific group of variables. So we're not just going to throw everything. We have to be kind of discriminative and just use what's relevant.
Okay, fine. No, wait, but you gave an answer. Now, my actual question is the following. There is work out there now on the impact of major economic downturns on lasting effects of these events. So scarring, the literature on scarring, meaning that in the wake of big shocks, you don't have this typical bounce back to the, say, pre-crisis trend. So because at least in macroeconomics, and I'm dealing mostly with fiscal policy, there's still this very entrenched idea that comes a shock, fine, but we will eventually come back to the pre-crisis trend. But we know from a lot of work starting in the 80s that this is not happening because of supply-side effects. Okay, so I was wondering whether in your approach you can sort of control or check whether, let's say, the lack of predictive power of traditional estimates of the output gap, which eventually I think still capture this idea that you will go back to the pre-crisis trend, whether the lack of predictive power of this variable is linked to events that actually have a lasting effect that comes from the supply side. Thank you.
I mean, great question, and I'll try to be super sparse on this. I mean, obviously, this has limitations. Can we link it directly to some specific things about the supply side? I wouldn't try to do it here. However, it's sort of learning things endogenously. It can learn to filter trends. Here we throw all the data at it, but we actually do stuff in the paper. We look at specific variables and look how the network is actually transforming them in terms of detrending. So again, there's sort of addressing problem with typical detrending methods that have a hard time really knowing, especially when you come out of a recession, what is trend and what is not. So yeah, in fact, it deals with that. Here we did the big data application, but you can do a small data version where actually we get pretty clear answer to that. So that was the short answer. Anyway.
Thanks very much. I'm sure you can ask Philippe questions during the lunch break then after. Yeah.
Mostly.
Yeah, of course. Thank you very much. So we move on. Alistair, it's your turn. So Alistair holds a PhD from Oxford and is currently a junior research fellow at St. Anne's College, also at Oxford. And he's going to lead up the second presentation.
Yeah, sure. Just while we wait for the slides to come up. There we go. I want to start by thanking the organizers for putting the paper on the program. And I feel like I should apologize because this is going to be another paper about heterogeneity and expectations, which we've been discussing at length all morning. I'm going to try and do something slightly different to what some of the other very interesting papers have done. I'm going to break that heterogeneity down in a slightly different way and hopefully get some new insights by doing that. So to form any expectation, there's a two-step process. You need to start out with some information, and then you need some kind of model to map from that information into the variable you're trying to forecast. And so when we see in some data that people are disagreeing about the future evolution of some macro variable, well, it could be that they've got different information from one another, or they could be using a different model, or it could be both. And it's that situation, really, with heterogeneity in both of these components of expectations that I'm going to be interested in here. So how do those two dimensions of heterogeneity and their interaction affect macro dynamics? And in answering that, I'm going to make three contributions. So firstly, I'll make a general theoretical point. And I'll show you that an interaction between these two aspects of expectation formation can generate a novel channel through which shocks affect the aggregate economy that you miss if you don't do this breakdown. But that's going to be a general theoretical point. I'll then go on to apply that to the case of inflation. And specifically, I'll use some UK household survey data to document evidence of precisely the kind of interaction effect that the theoretical exercise uncovers. And then I'll build a model to match that survey data and draw out some implications. And the key one is going to be that aspects of these two parts of expectation formation can lead to high inflation becoming baked in or entrenched into expectations among a specific subset of households with particular kinds of beliefs. And that's then going to feed back into macro dynamics through that heterogeneity effect from the theory exercise. So I'll just jump straight into what that channel means and what's going on there. So there's a literature that's come out in macro over the last few years looking at the effects of inequality in macro. And in that literature, there's this idea that a shock will have a bigger effect in aggregate if the households with the largest marginal propensity to consume out of their income are also the households whose incomes are most exposed to that shock. Because in that case, the effects of the shock are concentrated among the very people who are going to be most responsive to it. Now, my argument about expectations is very similar to that. Suppose that the households that get the most information, or the people that get the most information about a particular shock, are also the people whose subjective models of the economy tell them this type of shock has big impacts on other variables that matter for their decisions. Well, in that case, information about the shock will be concentrated among the people whose expectations, and therefore actions, will be most responsive to that information. And so that will imply that that particular shock will have a larger effect in aggregate than we would see if everyone had the same information or the same subjective models, or if those things were uncorrelated with each other. So I'm going to call that channel the narrative heterogeneity channel. Formally, what I do in the paper is I have a general class of macroeconomic models, and I look at the effect of a shock to an arbitrary variable that I call x. Now, when that shock x happens, if you're a household and you're paying some attention, you're getting some information directly about that x, well, the first thing that happens is that you see something of the shock, you observe it, and so you update your expectations of that variable. That's this red object in this term here, and so you can think of that as like a summary of the extent of direct information that these people are getting about that shock. But of course, that's not the only thing you do with that information. You also update your expectations of other variables, which I'm labeling z, depending on how you think those z variables are related to x in your model of how the economy works. And so when I talk about the covariance of information and models, it's really that object that I'm referring to. But I think that's enough general theory. I'll now go on to talk a bit more about the specifics of this in the case of inflation. And what I'm going to do, oops, that's gone on to an appendix slide, which I didn't want. There we go. What I'm going to do is I'm going to use some unique questions in the Bank of England's Inflation Attitudes Survey to uncover aspects of these processes at the household level. So the first question is this one. If prices started to rise faster, would that make Britain's economy stronger or weaker, or would it make no difference? And so that's asking you about your subjective model. What are the effects of inflation? Without asking you what you think inflation or any other variable actually is. And so without asking you about your information. The second question is a bit like the reverse. It asks you, well, what sources of information did you use to arrive at your expectations? And it asks you that without asking how you mapped from those information sources into an expectation. Now, from that decomposition I had, what's really important for this channel is direct information, in this case about inflation. So what I do is I split the possible responses to that information question into direct information sources, which are things like, oh, I used discussion of inflation in the media to form my expectations. And then the other category will be indirect sources of information, which are information sources about other variables. Things like, oh, I used information about the level of interest rates. Because, of course, if I want to use information about interest rates to forecast inflation, I have to pass that through some kind of model of how those variables are related, even if it's just a heuristic. So yeah, what I'm interested in here is really, do these households get direct information? And so I just define a very simple indicator variable, which is equal to 1 if they say, yes, I used one of those direct information sources, and is 0 otherwise. And from these two questions and from these two measures, I document two important things. The first one is that households who say inflation makes no difference to the UK economy are significantly less likely to make use of direct information about inflation when they're forming their expectations. And they're significantly less likely than households who say inflation is good and than those who say inflation is bad. Now that's important because it tells us there is a systematic relationship between information and models in the cross-section, which is what we needed for that narrative heterogeneity effect to be there. Going a bit further, this chart on the right here shows the proportions of households giving each of those answers to the subjective model question over time. And the first thing to say is that the most common answer in every quarter of this survey is that inflation makes the economy weaker. And the next most common answer is always that inflation makes no difference. And so what that means for our narrative heterogeneity effect is that information, on average, is concentrated among households who think inflation is really bad for the economy. So that's going to mean inflationary shocks have a less positive or a more negative effect on aggregate consumption than you'd expect if you didn't have this kind of disagreement. But you'll also see that these proportions on each of these answers change over time. Turns out that variation is actually quite predictable. When realized inflation has recently been high, a far greater proportion of households say that inflation makes the economy weaker. Okay, so that's some facts from the data. How do we interpret those? What do they mean for macro and policy? For that, I need a model. I'm going to do something very simple. It's a very standard partial equilibrium consumption saving framework, and there are two key ingredients that you need to know about. The first one is I'm going to assume that information about current inflation is costly for households to acquire. And you need that to match that cross-sectional fact in the data. Intuitively, this is quite straightforward. If I'm a household who doesn't think inflation matters for very much, why would I spend the time and the effort investigating and understanding data and news about inflation? Now, the only people who will choose to acquire information in this framework are people who value it. And they value it because they intend to use that information in their decisions. So that's going to be people with subjective models that tell them inflation is important in some way. The second feature is I'm going to put in just a reduced form process by which high perceived current inflation leads a household to update their subjective models towards thinking inflation erodes real incomes and is bad for the economy. Now, you need that in a simple sense just to match that time series variation. When inflation goes up, people on average perceive that inflation is higher and so move more in this negative subjective model direction. I do have a proper theoretical micro-foundation for that in the paper. I think the better evidence to convince you that this is a sensible thing to do is to say that actually this pattern is also there in the cross-section of households, not just over time. So within a quarter, households who believe that inflation is currently higher are much more likely to report that they think inflation makes the economy weaker. Okay, I'm near the end, so just very quickly, there's all sorts of rich macro implications from you get two-way feedback here between information choices and subjective models. I'll just show you one implication. So what I've done here is I've simulated a temporary spike in inflation in this model that dies away very quickly. Now, the black line is the perceived inflation on average among households who think inflation makes the economy weaker. And so the shock hits, their perceived inflation goes up a bit, and that means they update their subjective models towards the belief that actually inflation is now even worse for the economy than they previously thought. Well, that means it's then even more important to those people to track what's going on with inflation. It has a big impact on the economy in their view. And so they're paying lots of attention to it, which means that when the shock dissipates and inflation comes back to target, those people observe that very precisely. They notice that inflation has come down, and so there's no baking in of expectations here. Those people, their expectations come right back to target with realized inflation. But the same is not true of households that start out believing inflation makes the economy stronger. Because their perceived inflation goes up when the shock hits, they become more negative about the effects of inflation. But that means they go from thinking inflation's quite good for the economy and move more in the direction of thinking on balance, maybe inflation doesn't make so much difference. Which means they stop paying so much attention to inflation. It doesn't matter as much to them anymore. And that means that when inflation eventually comes back to target, those people aren't paying attention anymore, they don't notice, and so their expectations of inflation remain high for a much longer period of time. And that matters, is the final thing I'll say, beyond the usual reasons that we talk about when we think about de-anchoring of expectations. Because it means that this temporary shock in inflation has permanently or very persistently changed the distributions of information and subjective models in the economy. We've taken those people who thought inflation was good for the economy, and we've made them a bit more indifferent. And so that means that future inflationary shocks are going to have quite a different effect on aggregate consumption because we've seen a permanent change in that narrative heterogeneity channel that I identified in that theoretical exercise. I'll stop there. Thank you.
Perfect. Thank you very much. Okay. Do we have questions from the audience? Not so much. Some from the board. Otherwise, I can jump in, break the ice as well. Okay. What I found super, what I found interesting in the paper is obviously you're focusing on the English survey and the English data. What do you think about the implications of putting that kind of stuff to a Euro area, for example, that is heterogeneous in its heterogeneity, for example? What kind of implications would that have?
Yeah, I think the one lesson that I learned, at least doing this, is that there is an awful lot of heterogeneity in these different components of expectations, and I think, yeah, you're right. There's an extra layer of heterogeneity within the European context, looking across different countries, that would be very interesting. You saw a bit in the presentation James gave of another way of trying to get at these sources of heterogeneity. Turns out it's quite difficult, because if you look at this thought process of, oh, well, to form an expectation, I take some information, and I've got some model to translate that into an expectation. Well, that then tells you that actually just looking at raw expectations data is a bit insufficient if you want to learn about these channels, because expectations combine both of those elements into one. And so you can't understand their correlations across households with that. And so this is really the reason for doing it with UK data, because they have these questions that allow you, at least in a kind of coarse way, to disentangle those things. If there's a European policymaker running a survey in the room that would like to do something with European data, I would love to talk to you, because I think there's much more we can do to understand that in a deeper level.
Thanks very much.
A question I have in the chat is, on the whole, does your research imply that policymakers at this junction should react more aggressively against high inflation or not?
It's a great question. I think the note that I would say as a slightly positive view on this is that if you look at the household survey data, the UK stuff that I was looking at, the people who report that inflation makes the economy stronger, their expectations at the moment have risen by quite a lot less than the expectations of other households. So the first thing I would say is it would appear that the cat is not yet out of the bag on that kind of baking in or entrenching of expectations. But I think what that exercise at the end does provide is a bit of a warning that if you lose that group of households, they're going to be extremely difficult to bring their expectations back to target. So I think one way to interpret that is indeed that actually entrenching or baking in of expectations is a potentially big problem, that action to stop that happening would be, I think, useful, but no cause to panic, I guess, is maybe one way of interpreting that final stat.
Okay. Okay, we have one question.
Yes, I have a question about the heterogeneity of the people giving the message. We've heard a lot about the heterogeneity of the people getting the message, but does it make a difference whether it's Andrew Bailey or Dave Ramsden or maybe a lady from the Council of the Bank of England regarding the respondents? Have you done any research on that? And then in the United States, there's just recently been a couple of people from ethnic minorities, very unusually in the history of the Federal Reserve, being now given jobs as governors, members of the Board of Governors. That might make a difference as well, also, according to the message. It could be that research on this is at a fairly early stage, but it would be very interesting to know. Also, of course, in the Euro area, we've got a composite series of languages here, right? A bit like the Austro-Hungarian Empire. So it would be quite interesting to know about the language as well, but that may go beyond the terms of reference of your surveys.
Yeah, I think that's a fascinating question. I guess the first thing I should say is that if you look at the information sources that people say they use when forming their expectations, I think there is in some waves of the survey an option to say, oh, direct statements from the central bank, and almost no one picks it. So in terms of where people are getting their information from, the direct information sources are almost entirely discussion of inflation in traditional media. And we saw a bit about that yesterday in other sources. That said, if you want to try and increase communication from the central bank directly, it does seem like the evidence that Michael Weber showed yesterday suggests that, yeah, the sender matters, and certainly in terms of reaching diverse communities, diverse senders is very important. As it stands at the moment, and certainly with the way inflation expectations seem to be formed in the UK, it seems like the official sender is such a small part of that I'm not sure it's the kind of the front and center issue here. But you're right, going forward, it has to be a more important issue, I think.
Okay, thank you very much. I think that closes us perfectly on time. So next up is Sebastian. Sebastian is just about to complete his PhD at the European University Institute in Florence, and is going to join the Dutch National Bank in September, I think. Yeah.
Great.
The floor is yours, Sebastian.
Thanks a lot, first of all, for organizing this great conference and for including our paper. And if you can, perfect. So, and I'm going to present work that is joined with Jonas Fischer and Leonardo Melosi, so the usual disclaimer applies. And our work is basically motivated by the observation that central bankers typically consider long-run inflation expectations that are stable and close to their target as key for their mandate. And one measure that they often look at in the US are surveys by US professional forecasters, such as the 10-year CPI inflation expectations. And you can see here that these expectations have been fairly high in the beginning of the sample of the 90s, then they have declined, and they reached, at the end of the 90s, this level of around 2.5%, at which they remained until the Great Recession, and many people often considered this as a period of well-anchored expectations, and afterwards they declined further until now. During the last 2 years there was an increase again. I mean, overall these expectations, if you look here at the mean or the median over the last 20 years, they look fairly stable. But if you look behind average expectations, there's actually quite a lot of heterogeneity. And keep in mind, these are professional forecasters. So these are not households or firms, where we had a lot of presentations today and yesterday about. So we would think professional forecasters are very homogeneous and they should be very well informed. But in fact, here you can see 4 selected forecasters. And in the left figure, for example, forecaster 2 is a forecaster that really adjusts expectations from one period to the other quite a lot, while forecaster 1 is a forecaster that has very stable expectations over time. But both forecasters don't really have expectations that seem to follow actual inflation dynamics a lot, so there seems to be some judgment involved here. And if you look on the right figure, the 2 forecasters here, again, the red one is more frequently updating expectations, but in contrast to the left figure here, you can see that these expectations actually exhibit quite some co-movement across the 2 forecasters, at least at a low frequency. Overall, we think that these heterogeneous patterns highlight that it is important to look at individual expectations to understand the behavior of inflation expectations. And this is what we do in this paper, where we present a model to explain fluctuations in aggregate and individual forecasters' long-run inflation expectations. And in our model, we assume inflation can be characterized by a trend cycle process, and this is a view that is common and shared also by forecasters. And forecasters basically want to learn about this underlying trend of inflation which is unobserved. And by learning about this trend, they form long-run inflation expectations. And basically, we assume that forecasters have 2 pieces of information in our model. The first one is the current reading of inflation and also the history of inflation, which is a public signal. And the second signal we label news about trend or long-run inflation. And these news conflate both fundamental changes in trend inflation, but also beliefs. And beliefs can be common, so shared across forecasters, or idiosyncratic forecaster specific. And you can think about these beliefs actually capturing these differences in forecasters that I've shown you here, that sometimes are very forecaster specific, but also, as in the right chart, you have some co-movement across forecasters. And then overall, I don't have time to go into the detailed model now, but this is essentially a signal extraction problem. So forecasters receive these two signals and they try to learn about the underlying trend level of inflation. And we bring this model to the data using panel data from the US Survey of Professional Forecasters, and we ask 3 key questions. The first 2 are more backward-looking. We ask how sensitive are forecasters' expectations to these different factors that I described before. And the second question, what are the historical drivers of long-run inflation expectations? In particular, this decline, stability, and then further decline. And third, I'm going to talk a bit at the end of my presentation about the implications of the recent high inflation episode for the re-anchoring of US inflation expectations, and where I take the perspective of a US central banker in September 2021. So now let me come first to the first 2 set of results. So here I want to talk a bit about the sensitivity of inflation expectations of forecasters in response to the 2 signals. So on the left, you see the sensitivity to the inflation signals, or this public signal, and on the right, the sensitivity to news. And what you can see here is the Kalman gain. So this basically shows you how much, if you take, for example, the median value of approximately 0.15 here, if you look at this, this indicates if forecasters receive a signal that inflation is 1 percentage point higher, they would immediately upward adjust their long-run inflation expectations by 15 basis points. And overall, you can see here that the sensitivity varies quite a bit over time, but the sensitivity to inflation tends to be fairly low, even though there's an upward trend over time. So this can be considered as a good news for central banks, in the sense that inflation expectations over this sample seem to be fairly well anchored. If you compare the sensitivity to inflation to the sensitivity to news, the sensitivity to news tends to be a bit larger, overall around twice the magnitude, but also not a very high sensitivity. Now coming to the second key results about the historical drivers of long-run inflation expectations, you can see here the historical decomposition of average expectations, which are plotted in black, together with the inflation drift or inflation trend, and the 4 different factors that drive average expectations. And not surprisingly, permanent shocks are the main driver of average expectations, while cyclical shocks, which are in blue here, only play a very small role. Now, by construction in our model, the difference between trend inflation and average expectations has to be explained by beliefs. But whether these beliefs are common or idiosyncratic beliefs are really what the data tells us. And here we find that over the sample period, you can see the red part is larger, so these common beliefs play an important role, both in the beginning of the sample, where they slowed down a bit the decrease in average expectations, and also especially in the later part of the sample, where trend inflation declined below this level of 2.5%, which we consider as well-anchored expectations for the CPI. And during this period here, around the Great Recession and afterwards, these common beliefs had an important role as a stabilization factor, so slowing down this de-anchoring of long-run inflation expectations that over time then happened. And you can see at the end of the sample, which is end of 2020, the average expectations and trend inflation have converged. And now in the last 2 minutes maybe that I have time, let me talk a bit also about the most recent episode, so the high inflation since 2021. So as a context, in the US, average CPI long-run inflation expectations have reached a level of 2.5% in the second half of 2021, and they have been below this level for very long before. And the Fed adopted this new long-run framework in August 2020, which basically says that they want to anchor inflation expectations by over or undershooting the inflation target. So if there's a period of very low inflation for some time afterwards, you want to, or it's fine to have inflation above target for some time. And so we asked the question now in September 2021, where this level of 2.5% was reached, what is the path of inflation that would essentially cement average expectations at this level of 2.5% going forward? And so essentially we use our model and filter forward the implied inflation and trend inflation path based on the assumption that average expectations remain at 2.5%. And you can see here in blue two inflation paths, and one is with communication, and this is a scenario where we allow belief shocks to happen, while the second scenario, no communication, shuts down these belief shocks. And as you can see with this gap is that in the case where you don't allow for these common beliefs to play a role or no communication happening, you need more of an inflation overshoot to keep inflation expectations anchored. So again, this here suggests these common beliefs can play an important role, and to the extent that central banks via communication can coordinate beliefs, it can lead to less of an inflation overshoot that is required, as you can see by the dashed blue line. Overall, if you compare the inflation path that is predicted by our model with the summary of economic projections from the Fed in September 2021, we find that the inflation overshoot that is predicted from the SEP would have not been enough to actually re-anchor expectations at this level of 2.5. Of course, maybe also by now we know also this inflation path from the SEP back then was very far off, and now I think going forward, especially with the most recent SPF numbers from this quarter, it would be interesting also to see how much now basically you can tolerate before inflation expectations really drift away from target. And with that, let me stop here because I think we're out of time.
Thank you very much, Sebastian. So before we take questions, I just wanted to fill you in that we decided, given that the video quality of the second video might be bad as well, that we decided to put that on the website so everybody can watch that on her terms, essentially. And so we have the usual time as well for Sebastian to take a couple of questions. So we have one here on the right already.
Thank you for this interesting presentation. So, linking your presentation with the ones this morning, I think we have a micro-macro puzzle here. Because in the morning we heard at the micro level, individual level, that inflation expectations are very much influenced by inflation perceptions and also long-run inflation expectations. So at the micro level, it looks like they are not, if you think that one definition of anchoring is that short-run news or short-run expectations do not feed into long-run ones, at the micro level, definitely it's unanchored. Now, what you said, and most central banks keep saying this, that at the aggregate level, short-run inflations don't feed through to long-run expectations. So is there a way to reconcile the two? Is it aggregation, or what is your idea to resolve this micro-macro puzzle? Thank you.
Thanks a lot. So first of all, maybe I was not clear enough. Essentially here you also have some micro results, because what I plot you here, so we use a panel of professional forecasters, and here you see the Kalman gain, so the 25th median and 75th percentile. And you can see, I mean, these bands are not huge, but overall there's also among professional forecasters quite some heterogeneity. So you can have some professional forecasters that also respond more to short-run changes in inflation. But overall, I would say the main difference is really likely to be the difference between professional forecasters and households, where I think this comes back to the story, what are kind of the factors that drive long-run or also short-run inflation expectations of households. These are grocery prices, gasoline prices, etc., while professional forecasters, and at least that's also what we kind of assume here, they really receive the public reading of inflation. So that's the information that we assume they have. And that might also drive some of these results here.
Second question in the middle.
I get the impression that many of the forecasts are excessively volatile, right? They go up and down from quarter to quarter a lot when about a long-term forecast, which we actually smoother than the outcomes. So in this, it would be interesting to try and include here what would be the rational sensitivities. I mean, there's some, if the people knew the truth, what would be the sensitivities? And if the people are actually oversensitive to both news and inflation, shouldn't perhaps central banks not pay so much attention to these professional forecasters?
Yeah, I mean, I think that's a great point. I mean, also to what extent their expectations matter for the inflation outcome or channel outcomes later on. But I mean, regarding this point of rationality, maybe let me say that also here in our model, in principle, you can have these factors like extrapolation or overreaction to news. So that's also can be captured. So we don't assume here forecasters have to be rational on the medium, but I think that might I don't know to what extent this now fully addresses your question, but yeah, thank you.
Any more questions from the audience? No? Okay. So I have one more, Sebastian, if I may. So you showed that, or basically you mentioned also in the paper that the relative gain that you get from the inflation signal relative to the information or news signal actually increases over time, especially towards the end of your sample, essentially. I wondered why this is the case, given that we are in this sort of, or do you have an explanation for that, given that we are, for quite some time, or that we have been for quite some time in this low inflation period? What has changed during that time to?
Yeah, so I think, in fact, the slow inflation period can be a main driver here, because if you look at this upward trend, basically, the low inflation, I mean, also in the 90s it was already lower, but it was much higher compared to still from 2010 onwards. And actually, interestingly, we currently work on an extension of the sample period also, and from some preliminary evidence we find also with the 2021 inflation that the sensitivity to short-run inflation really drops sharply again. So this upward trend is kind of interrupted, and the sensitivity to news becomes a bit more important again towards the end of 2021. So
okay. Thanks very much. So if we don't have any more questions, that keeps us perfectly on time. We close the session here. So as I said, Fabio Verona's presentation will be available online.
Good afternoon. My name is Fabio Verona. This is a recorded video of my joint paper with Manuel Martins, where we analyze inflation dynamics and forecast in the frequency domain. Policymakers typically see inflation characterized by a trend strongly influenced by inflation expectation that in turn are shaped by the conduct of monetary policy and deviation from that trend caused by persistently high or low resource utilization, as well as temporary movement in energy prices and other shocks. Macroeconomists sees inflation dynamics as described by the expectation augmented or New Keynesian Phillips curve. The state-of-the-art empirical micro-funded New Keynesian Phillips curve, the second equation in this slide, relates inflation pi t to inflation expectation pi t plus 1e, a measure of economic slack, such as the employment gap, U gap, and a measure of supply shock, such as energy inflation, SSNT. The New Keynesian Phillips curve and the policymaker view on inflation are close but not equivalent. For example, agent expectation of next period inflation, pi t plus 1e in the New Keynesian Phillips curve, are not long-run expectation and not necessarily shaped by the central bank's inflation target. Energy inflation, on the other hand, may affect expectation and may on occasion have persistent impact. The unemployment gap may result from various types of shock, and its fluctuation may exhibit varying persistence over time. In this paper, we use a frequency domain decomposition of the time series of inflation and its determinant to describe the in-sample dynamics of inflation in the US and to forecast out-of-sample US inflation. To understand and give you the intuition of our approach, consider the decomposition of inflation and of the time series of inflation and of its determinant into four cyclical components. The high frequency component that is capture fluctuation less than 2 years, the business cycle frequency component that captures fluctuation between 2 and 8 years, medium frequency, that are the fluctuation between 8 and 16 years, and the low frequency, which capture the Longrun, the low frequency trend or low frequency trend that are fluctuation more than 16 years. And inflation is the sum of these 4 frequency components. And the low frequency component of inflation should be closely related with inflation expectation, especially with their low frequency component, and probably less so with resource utilization and energy shock. At the other end of the spectrum, the high frequency or short-run movement of inflation should be closely related with energy prices shock, especially with the high frequency component, and less so with cycle of unemployment and expectation. And while at intermediate frequency, unemployment is expected to play a key role, with the relevance of inflation expectation and supply shock possibly changing during specific episodes. What we find, the main result about inflation dynamics are the following. Inflation expectation dominates medium to long run cycle. Energy inflation dominates at short cycle, but also at business cycle and medium cycles once expectation became anchored around the 2000s. Most importantly, unemployment fails to account for a substantial part of the variation of inflation, even at business cycle frequencies. As regards the auto-sample inflation forecast, our main result can be summarized as follows. The key to have a good inflation forecast is to forecast well its low frequency component and to ignore the other frequencies of inflation. And differently from the in-sample analysis, the long-run component of unemployment is key for such remarkable forecasting performance. So the main takeaway of the paper is that while unemployment may seem of little relevance in sample, it remains crucial in predicting inflation auto-sample due to its role at cycle longer than the typical business cycle. We use US data from 78 until 2020. Inflation is computed using the CPI index. Inflation expectation, we use the Michigan survey of consumer. The unemployment gap, we take the difference between unemployment rate and a linear trend. The energy inflation is the respective component of the CPI. And we run several robustness checks with other measures of slack and also with PCE inflation. And we use standard regression analysis and forecast method to study the sample dynamics of inflation and to forecast inflation auto-sample. And we estimate the Phillips curve either with aggregate variables or with their frequency component. And the advantage of our method is that the frequency have an economic meaning, they adapt to the original time series, and in our forecast, we can flexibly include or exclude some specific frequency and interrelation across frequencies. So for the sake of brevity, in this presentation, I only talk about the out-of-sample part of the paper. And in our out-of-sample forecasting exercise, we want to forecast the H period ahead average inflation rate, where we analyze 3 forecasting horizons, 1 quarter ahead, 4 quarters ahead, and 8 quarters ahead. And we make the forecast using a sequence of expanding window. And in particular, our auto-sample period runs from 2000 Q1 until 2020 Q4. Our benchmark forecasting model are are standard in the literature. They are the random walk model and the unabsorbed component stochastic volatility model. We run the forecast with the New Keynesian Phillips curve estimated with the aggregate variable, and in particular at each step of the auto-sample period, for each 8 forecasting horizon, we first estimate a ratio like the first one. Well, on the left-hand side, we have the measure of inflation. On the right-hand side, we have inflation expectation, unemployment gap, energy inflation. And then we compute a forecast using the estimated coefficient from the first regression. And our frequency-based New Keynesian Phillips curve forecast goes as follows. For each frequency component of inflation, we specify a Phillips curve, such as in the first equation in this slide. In this baseline specification, each frequency component of inflation depends on the same frequency component of the determinants of inflation. However, we then generalize this specification by allowing other frequency component of the predictors into the New Keynesian Phillips curve of inflation at frequency f. This methodological contribution should prove highly useful given that inflation and its determinants have different relative powers across cyclical bands. Moreover, both theory and practice suggest that they interact each other across frequencies. As inflation is the sum of its 4 frequency components, then the H quarter ahead forecast of inflation is just a sum of the H quarter ahead forecast given by each frequency component of the Phillips curve. We also assess whether the forecast of inflation may improve by using only the forecast of its low frequency component, which is the model denoted with LF here. The latter forecasting model, which considers only the forecast from the low frequency component of inflation, has strong motivation in the literature of wavelet-based forecast, as well as some motivation in the literature on inflation forecast. Following common practice, we assess the forecast accuracy by computing the root mean square forecast error for each model and computing the statistical significance according to the Dibble and Mariado test of the differences in the root mean square forecast error across models. And this table reports the main result of the auto-sample part. Panel A shows that the root mean square forecast error of the random walk model and the UCSV model, the standard benchmark for inflation forecast. So the UCSV model yields inflation forecasts that are noticeably better than those of the random walk model, only at 1 quarter ahead horizon. And as regard the panel B and C report the root mean square forecast error of the time series and the wavelet-based New Keynesian Phillips curve with respect to that of the random walk model. And the value below 1 indicates the model that the model outperformed the random walk model. Panel B confirms that the traditional time series Phillips curve fails to outperform the random walk model. And the first line of panel C, sorry, this is the comparison with the random walk model. So the first line of panel C indicates that the wavelet-based model does not perform significantly better than the random walk model. However, the second line of panel C shows that focusing only on the low frequency component of inflation produces forecasts for inflation that are substantially and statistically more accurate than those of the random walk model. And in panel D here, I was showing before, we are comparing the result of our wavelet-based Phillips curve with respect to the New Keynesian Phillips curve in the time series. And focusing only on the low frequency component of inflation produces forecasts of inflation that are statistically also more accurate than the New Keynesian Phillips curve estimated with the aggregate variable. So overall, the auto-sample results show that the key to obtaining a good forecast of inflation is to forecast well the low frequency of inflation that is cycle longer than 16 years, which include the trend essentially, and to ignore the other frequencies. Furthermore, and differently from the in-sample analysis, the low frequency component of unemployment gap turns out to be crucial in addition to the low frequency component of inflation expectation to realizing these forecasting gains. So to conclude, is the Phillips curve alive and well, as many economists are trying to answer this question, and we argue that it depends on the cyclical frequency and whether the Phillips curve is used to describe the dynamics of inflation or to inflation. Thank you very much for your attention.
So thank you very much again for attending the session. Thank you very much to the presenters. Yeah, and enjoy your lunch. Thank you very much.
You're welcome.